G'day and welcome to this video showcase of the BlenderOni plugin. This video is supposed to showcase you what is it, what's its purpose, what can BlenderOni do, and what are some of its use cases. So without further ado, let's just get into it. This video will be split into three parts. The first part will describe BlenderOni's purpose and why was it created in the first place. The second part will give a general overview of all the functionalities within BlenderOni. And the third part will describe all of the typical use cases for this plugin. One thing I wanted to note before we start, this video turned out to be way longer than I expected, so in order to not waste your time, you can use chapters in this video's timeline to check what you need. If you want to make animations for only, you can probably skip part 2 and just move on to use cases, and go back to part 2 if you feel you're missing out on how individual options work. Now, if you're not here for only, but rather to check what BlenderOni does, you can take a good look at the general overview of the add-on in part 2. In any way, I hope you will find the information here useful. So let's start off with the purpose of BlenderOni. BlenderOni is a companion tool for the Rigify animation rig for Oni, which is linked in the description. For those who don't know, Oni is a video game from 2001 by Bungie. Check it out, go get it, play it, it's amazing. Now the rig I've mentioned is a rig made with the Rigify add-on, and it allows animating characters in Oni with both forward and inverse kinematics called FK and IK for short. Before that rig, animating for Oni was possible only by moving body parts of the characters one by one, which through the parent-child relationship effectively formed an FK-only rig. However, animating for Oni exclusively with FK is ridiculously inefficient and time-consuming, and for this reason, a rig utilizing both FK and IK was designed for Oni. This allowed us to animate much more easily, taking some 20 to 100 times less work compared to animating exclusively with FK. Unfortunately, because of Oni's proprietary way of storing animations and how its character models are arranged, the rig is highly complicated and thus it requires a huge amount of operations to be done with setting Oni animations and models up in Blender. And this is the reason for BlenderOni. It automates all of those operations into single buttons, saving immense amounts of animator's time, which would otherwise have been spent on manually selecting every object and turning constraints and whatnot on and off over and over and over again. However, this does not mean that BlenderOni can be used only together with the Rigify Oni rig. In fact, 7 out of 9 functionalities in BlenderOni can be used in general Blender situations, so you may find your own use for it. And this is where the second part of this video comes in. I will now showcase each of the functionalities of BlenderOni and what they do. Before I proceed, I wanted to note that you will notice that in most of the clips, this subpanel is actually called Constraint Target Setters, and that the Constraint Character Model is missing. That's because Constraint Character Model was implemented as I was finishing this video, which is when I've realized that I've never automated what this option does and that it could be useful, and I also did not want to re-record the clips that I've had. This is also why I've changed the name of the subpanel to Constraint Setters. With this explained, let's go over the functionalities. Once you install BlenderOni, you will be able to access it through the side panel. And you will see it completely unfolded in here. So let's just completely close those subpanels, and you will see that the functionalities of BlenderOni are organized into these 4 subpanels: Other, Constraint Switches, Visual Transformers, and Constraint Target Setters. Other is reserved for all the functionalities that I was unable to group anywhere else. Constraint Switches turn on and off all of the constraints within the selected objects or bones within the specified, selected armature. Visual Transformers apply visual transformation and keyframe location and rotation data for every frame within the specified frame range for either all of the selected objects or bone within the armature. The job of constraint setters is to set the targets of predefined object or bone constraints within the selected objects or armature in case of the first two options, and to create predefined constraints for selected objects in case of constraint character model. Because all of the constraints are predefined, this is not intended to be used outside of the context of the Rigify-only rig. You can always try creating a situation where you will find these options useful, or even edit the source code of BlenderOni if you want, though. Now that we have explained all of the subpanels in BlenderOni, let's dive into each of the functionalities, starting in the other tab. The purpose of bake keyframe rotation mode option is to keyframe the rotation data of all of the selected objects within the specified frame range and in the selected rotation mode. So we have an example animation here. We have a cube flying around in the scene. And if you take a closer look at it, you will see that it is stored in XYZ Euler. And let's say I want to convert it to quaternions instead. So what I have to do is specify the frame range and select the intended rotation mode and press this button right here. And you will see that quaternion rotation data appears on the timeline. You will notice that every key gets framed within the frame range. That's because there is no keyframe checking functionality in Oni. BlenderOni, but it might get implemented in the future if needed. The purpose of change rotation mode is to change the rotation mode of every selected object. So if I select all of these cubes and go through them, I will see that they're all in XYZ Euler, and let's say I want to change them to quaternions. So I select all of them, pick quaternions, and if I check them again, I will see that these two cubes are still in XYZ. That's because Blender changed the rotation mode only for the active object, not all of the selected object. Blender simply cannot do that. So to fix that, you can use this functionality instead and select your intended rotation mode. Let's say quaternions, and press the button, and now you will see that all of the selected objects are now in quaternions. Let's switch them back to XYZ. There we go, they're all in XYZ. Adjust throw target option is best explained within the context of Oni. So the way throw animations are stored in Oni is that the target animations always face one direction, and the location always starts from 0, 0, 0, which, as you can see, within the point of view of the animator, doesn't really make a lot of sense. So that means you have to, in some cases, those cases are forward throws, you need to rotate them by 180 degrees, and two, you need to add a position offset to them. And this is what adjust throw target does. So the way you use it, you specify if it's a forward throw or a back throw. In this case, it's a forward throw, so we'll rotate it by 180 degrees. We need to then specify the frame range. It's 144 in this case. And we also need to specify the position offsets. And then we just need to press this button, and there you go. The animation is perfectly readable and possible to edit. One important note is that you need to make sure that before you use it, all of the you need to make sure that all of the frames within the specified frame range are keyed, because if let's suppose I pick this frame, delete it, and then I use adjust throw target, it will bug out, unfortunately, as there is no keyframe functionality. So keep that in mind. Moving on to constraint switches, they're really simple. All that object constraint switch does is that it switches object constraints within the selected objects on and off. So you can see that as I'm clicking, the object constraints in the selected objects get switched on and off. Bone constraint switch does the same, but for bones in the selected armature. So you go to pose mode, and you simply start clicking this, and you can see that the bone constraints get switched on and off. This saves immense amounts of time, as this would otherwise have to be done manually by going through each bone or object, and you would have to switch all of the constraints on and off. This way you can do all of this with a press of a button. Visual transformers apply visual transformation and keyframe rotation and the location data to the selected objects or bones within the selected armature within the specified frame range. This is used mostly to transfer animation between objects and armature bones. So to give you an example, I have an animation of an armature in here with a single bone, and I want to copy this animation over to this Cezanne object over here. I cannot just go into pose mode and copy keyframes onto Cezanne, because if I do that, Cezanne will be in a completely different location and rotation than she's supposed to be in. The reason for that is because if I showcase the axis of both the bone and Cezanne, let's enable it. You will notice that their orientations are completely different. So you have Z going up in case of Cezanne, and in case of the bone, it's actually Y. That's the reason for those inconsistencies. Now, the way you can work your way around that is by constraining the object to the bone and then applying the visual transformation to it and then keyframing it at the right frames. So let's do exactly that. Let's add copy location constraint and copy rotation to Cezanne, and let's target the bone in the armature. And this rotation is not quite right, so let's fix it. We can do that by adding empty arrows. Let's scale them up a little bit, and let's add another copy rotation to Cezanne. What we're gonna do is simply add rotation. We're gonna rotate the empty and then add that rotation onto Cezanne. So let's target the second copy rotation to the empty, and let's change the mix to after original. And now let's rotate the empty as we need it. There we go. And now we will see that Cezanne is doing the animation as we wanted. Now, what we need to do is, because the animation is still stored in the bone. Cezanne does not have any animation data yet. She's playing it only through the constraints. So if we turn them off, we will see that the animation is completely lost, and we don't want that. So what we need to do is pick the right keyframes, press Ctrl A, apply visual transformation, keyframe it. Then for this first keyframe, visual transform, keyframe it, and once we disable the constraints, we have our animation. Now, where visual transformers come in is where you want to do it either for a frame range or when you have a lot of frames to cover. So let's say it would be useful if you had, say, 20 frames to cover, or if you wanted to frame every to keyframe every frame from 0 to 73 in this case. So let's do exactly that. Let's turn the constraints back again. So I cannot move Suzanne. She's constrained to the bone. And with Suzanne selected, let's just specify the frame range, 73. And just press Object Visual Transformer. And there we go. We've applied visual transformation, and we can disable the constraints, and there we go. There's our animation. Now let's suppose we want to do the opposite. We want to copy animation from the object to the bone. So what we need to do is go to pose mode, add bone constraints, copy location, set it to Suzanne, and copy rotation. Suzanne. Same problem as before, so let's go back to object mode. Let's add an empty, scale it up a little bit so it's easier to read. Go back to pose mode for the bone. Another copy rotation. Set it to empty. Set the mix to after original. And go back to object mode. Rotate it. And there we go. And now what you can do is go to pose mode for the bone and either manually apply visual transform to pose where you need it, and then you will be able to see the results later. Or you can, instead of doing this manually, you can just use the bone visual transformer. So let's do exactly that. We've already set our frame range, just press the button at this point. And there we go. We have our animation. We can disable the constraints in the bone. We can delete Suzanne. And that's it for the visual transformers. Constraint setters are used to set the targets of the predefined constraints within the selected bones or armatures, and also to constrain only character models to the Rigify Only rig. Because the constraints are predefined, these options are not intended to be used outside of the context of the Rigify Only rig. As I've explained before, please note that the constraint character model was implemented as I was making this video, which is why it's missing when I'm explaining the first two functionalities. Sorry for any confusion. So in the Blender scene containing the Rigify Only rig, you will find a Kanoko model in the T-pose collection with each body part containing 2 copy rotation constraints, and the pelvis also containing a copy location constraint. What set object constraint targets does is that it sets the name of the target for the first copy rotation constraint and also for the copy location constraint in the pelvis. So if you want to duplicate the rig for any reason, usually for the purpose of making throw animations, and then you want to constrain the model to it, let's duplicate the rig. And all you have to do is select all of the character model parts, and then you have to set the name of the target rig. It's already set. Then press the button, and there you go. You can see that the target names have been updated. SetRig bone constraint targets does a similar thing, but for bones. So if you take a look at the rig bones and their constraints, you will see that most of the bones contain constraints with names ending with either 0.001 or 0.002 suffix. SetRig bone constraint targets sets the suffixes of the targets for the specified constraint within the specified rig. The targets are always assumed to follow the naming convention of Oni models, which is why this is only changing the suffix. So let's suppose I want to change targets of 0.002 constraints in rig 0.001. What I need to do is input the name of the rig, 0.001. Then I want to change it for 0.002 constraints, so I select that over here. And then I need to specify the suffix of the target objects. Let's suppose I want to target them. I want to target the model in the T-pose collection, which doesn't have a suffix. So what I do is simply leave it blank. And let's press the button. You will see that the target has now updated. And to change it to model with any other suffix, I just need to input its suffix. So let's assume I want 0.001. So that's what I do, 0.001. Press the button, and there we go. Our targets have now updated for constraints with 0.002 suffix. Constraint character model is used to constrain an Oni character model to the Rigify Oni rig. To use it, simply import a character model, then input its suffix. In our case, that's 0.003. Then set the name of the rig to which you want to constrain it to, and press the button, and the model is now constrained. With all of the functionalities explained, I will now explain typical use cases for BlenderOni within the context of Rigify Oni rig. Before we proceed, it's important to first understand how moving animations between Oni and Blender works, along with constraining them to the Rigify Oni rig, and then disabling those constraints. Here's the current workflow for creating new animations for Oni. Let's assume you want to make a new animation for it. First, you will need to convert a model with an animation serving as the starting point for your animation, and also a T-posed character model which you will animate. You see, vast majority of the time, you will want to start or end your animation with a frame from the animation that will play before or after your own animation in order to make it transition smoothly. For this reason, you will want to import two character models, one without any animations that will be constrained to the rig and animated. It will be T-posed as it will contain no animation upon importing to Blender. The second character model will contain the animation, serving as the starting point for your own. The rig will be constrained to this model, after which you will copy from the model either the animation frames you need or the entire animation over to the rig, depending on what you need. Once you have converted the animation and the model from Oni using OniSplit and then imported it to Blender, you will need to constrain the T-posed model to the rig and the rig to the animated model. Once that's done, you need to enable the constraints in the rig through the pose matching functionality in the rig. The rig is now constrained to the starting point animation and the T-pose model is constrained to the rig. Now you need to copy the frames you need from the starting point animation. You can do that by applying visual transform on the rig's bones in the forward kinematics and torso group bones. Then you need to unconstrain the rig from the animated model by disabling rig's bone constraints. At this point, you can now animate with the rig. Once your animation is done, you will need to get it back to Oni, which is somewhat easier. Right now, the animation you've made is stored only within the rig. The model you were animating does not contain it. It is playing it only because the model is constrained to the rig. So because of that, you will need to copy the animation over from the rig to the T-posed model. You can do that by applying a visual transform on the model. Once the visual transform is done, the T-pose model will now contain the animation data, and you need to disable the object constraints in it. After that, export the animation to Collada, convert it with OniSplit, and put the animation into your mod package, and you can now play your animation in Oni. Now that we have this basic animation workflow for Oni explained, we can move on to typical use cases for BlenderOni. The first one will be exactly this schematic. Alright, let's assume I want to make some animation for the TCTF trooper, and I'm using his punch combo as a basis for my animation. This video is not about using Oni Split, and it is already explained how to use it to export Oni animations from Blender to Oni in our community tutorials. So I'm starting off from the point of importing the animations to Blender. I'm going to start off by deleting the models in the T-Pose collection and in the Pose 1 collections, as this is not what we'll be working with. Let's get rid of them. Now I'm gonna pick the T-Pose collection, and I'm going to import my T-Pose model. Be sure to always check import units when importing. There's my T-Pose model, and I'm gonna pick the Pose 1 collection. And there we have our animated model. The fact that the animated model is completely untextured can be completely ignored, as it will not impact the animating process in any way. However, if you want it fixed for any reason, you can look how to fix it in using the Rigify animation rig article linked in the description. Now let's constrain the T-pose model to the rig. Let's hide pose 1 for now, as it will not be needed. And now we need to specify the suffix of the character model. There is no suffix in the name, so we're gonna leave that blank, and our rig is named just simply rig. So all we have to do is press the button, and there we go, it's constrained. Now we need to constrain the rig to the animated model. So just to make sure that we're doing everything okay, we're gonna hide the T-pose model. Let's enable pose 1, and let's enable the rig. And let's take a look at the bones, or specifically their constraints. And we will notice that the targets are now missing because we've deleted the model in the pose 1 collection earlier, and it had a 0.001 suffix, so we're gonna set that right now. So the name of the target rig is going to be rig. The suffix of the constraint is going to be 0.001, so that's already picked, and we're going to set the targets to the model with the 0.001 suffix. So that's already set, so let's just press the button, and there we go. The rig is now constrained to the animated model. However, we still need to enable that, as the influence of those constraints are still at 0. We do that by simply picking one of those two pose matching bones in the rig and moving them across the z-axis. And now the rig is fully constrained to the model. As you can see, the influence is set to 0. The way this works is that you have a driver that's depending on the position of these two bones. So you have a pose 1 for constraints with 0.001 suffix, and pose 2 for constraints with 0.002 suffix. Now I need to apply visual transformation to the rig bones. Because pose matching functionality works only through forward kinematics bones, let's disable all of the IK bones and the pose matching bones, as they will not be helping us in any way. So let's go to item, rig layers, pose matching, and all of the IK layers will get disabled. Now let's select all of the rig bones that are left, and right now you need to figure out what exactly do you need. If you need just the first frame, then just set the range to the to that frame, or if you want a bigger range, or say the entire animation, in this case it's going to be 18 frames, set the frame range appropriately. So I've set it to from 0 to 18. Now I'm going to press Bone Visual Transformer, And there we go. Now the animation is visually transformed. It's in the rig. And what I need to do now is disable the bone constraints. And let's hide the pose 1 collection. Get back the T-pose collection. And now I can animate the character. You can now use all of the rig's functionalities, which will make your life significantly easier. Mainly the IK bones. Let's have a quick look. So here's IK for the legs. 1 second. The second leg. And also for the arms. But let's get back to FK. And also let's disable the IK. Now this isn't a tutorial on how to use this rig, so I'm just gonna assume that this is my animation and now I want to export it. First, I will need to apply a visual transformation to the T-pose model. So let's hide the rig. Let's go back to object mode. Let's select the T-pose model. Now we need to specify the frame range in which I will apply the visual transformation. It's already set. So now I'm gonna press the button and there we go. The visual transformation has been applied. However, I still can't move the model. So I will need to disable all of the object constraints. And I can do that with this button. And there we go. Our animation is now ready to be exported to Collada. You can do that here through export and Collada. And that's it really. Once you export it, you can convert it with Oni Split and you can play it in Oni. The second use case for BlenderOni will be creating throw animations for Oni. The schematic for throws is still roughly the same, with the main differences being you will have 4 models instead of 2, and also 2 rigs instead of 1. And then you will need to adjust the throw target model upon importing, and then adjust it back again before exporting it out of Blender so that the throw target is readable by Oni. So as before, I'm gonna do the same thing and start off with deleting all of the models that I don't need. I'm gonna need 4 models. That's gonna be 2 T-pose models and 2 animation models. So I'm gonna delete these. Let's also hide the rig. Enable the pose 1 and delete this. Pose 2. And let's duplicate this collection. So that's gonna be, let's name it T-pose 1 and T-pose 2. I'm gonna pick T-pose 1. Import my first T-pose model. Let's say this one. And to fix this blackface here, all you need to do is go to the shading tab. It's also explained on the wiki in the article I've mentioned before. All you have to do is constrain alpha to pretty much anything that will work in here. I'm gonna pick emission strength since that works. Now going back, we have our model, and now we're gonna import the second model. That's gonna be the TCTF Trooper. There we go. And now the animations. The second animation. All right, let's be sure to pick the right collections before you import. That's gonna import them directly to the collections, and that's gonna make your life easier. And there we go. We have our models and animations inside the appropriate collections. Let's disable the T-pose models for now. Now, as you will play the animation, you will notice that something is not quite right. Both of the animations are facing the same direction, and the throw target animation is not rotated. That's because this is how animations are stored. The way throw target animations work in Oni is that they store the same way as the rest of the animations. They're facing the same direction, and they're also starting from point 0, 0. And the way they get adjusted is that you have these uh, position tags inside the attacker's animation, which give an offset to the location of the throw target and also the angle by which the throw gets rotated. So let's adjust the throw target now. I'm gonna need to hide the attacker's animation. Let's pick the pelvis. And now I need to pick the right operation for the adjust throw target. That's gonna be, this is a forward throw. So I'm gonna pick the forward throw option, not the back throw. And now I need to specify the frame range. That's gonna be 99. And now I need to apply the appropriate offsets. They're all explained in here, how to paste them from the tags. So for X, it's gonna be Blender X, only X. So we're gonna just copy this. Then for the Y, that's gonna be an inversion of Oni's Z. So that's gonna be this value. And let's add a minus sign in here. And then for the Z, we can actually leave it out as the animation. That's for the height. We can see that the animation is the animation's height is correct. So let's leave it at Z. Now all you need to do is press adjust throw target, and once you enable pose 1, you will see that the animation is now perfectly aligned, with the exception of the final frame, which is rotated by 180 degrees due to a bug in the script, and that's relating to how Oni stores its animations. To fix it, simply rotate the pelvis in global Z by 180 degrees, keyframe it, and there we go. The animation is now properly, the throw target is now properly adjusted. Now let's constrain the T-pose models to the rig. Now I'm gonna open T-pose 1. I'm gonna input the suffix of the model. That's there is no suffix, so I'll leave it blank. Name of the rig is going to be rig. There we go. The model is now constrained. You can always check that. Check if it worked correctly. Targets are assigned. Bones are assigned, and now we need to do the same for the second T-pose model. And we'll also need to duplicate the rig. So let's do that. Hide the first rig, the second rig as well. Now I'm gonna need to do the same. The suffix of the character model is 0.001. The name of the target rig, on the other hand, is rig 0.001. Now let's constrain the character model, and there we go. The character model is now constrained. Now let's constrain the rigs to the animated models. Let's open up, first let's hide the T-pose model. Let's open up, let's unhide the first rig. And now we need to use set rig bone constraints, and we're gonna do this for the first rig. Its name is rig. Now we want to set targets for the appropriate constraints to the appropriate animated models. Because both of the rigs contain 2 pose matching bones, we can actually set constraint targets in both of the rigs to both of the animated models. So the name of the first rig is going to be just rig, And for the first set of constraints, we want to target the first animated model of which suffix is 0.002. So let's set it to 0.002. Press it, and the targets are now updated. Let's do the same for the second set of constraints, which will be constrained to the second animated model, of which suffix is 0.003. So that's going to be 0.003. And that's going to be the second set. Let's update it. There we go. The second set is now targeting the second animated model. And now let's do the same for the second rig. Let's hide the first one, and now we have the second rig. And again, the first set of constraints is supposed to target the first animated model. And the name of the rig is, of course, rig 0.001. So let's update that first. Let's select the first set of constraints and target it to 0.002. Press it. Oops. Rig 0.001. Oh, that's a comma, not a dot. There we go. And now do the same for 0.002. That's supposed to be targeting the second animated model. The suffix is 0.003. And there we go. Both of the rigs are now targeting the animated models. Now that the T-pose models are constrained, and so are the rigs, we can now use the match posing functionality. So let's select the rig. And also let's go to the pose mode and enable the appropriate T-pose model. And now pick the right bone. So the pose matching bone for this rig is pose 2. Let's raise it up in Z. We can see the T-pose model is now constrained. And now let's do the same. Actually, let's hide the animated model first. Now let's go in object mode to the first rig. And let's enable the T-pose model. Select the right bone. That's going to be pose 1 for in this case. You can always play around with the other bones, see what happens. You can see it now got constrained to the throw target. We don't want that. So let's raise pose 1, and we can see that both of the T-pose models are now properly constrained, and they're sitting where they're supposed to be. Now let's do visual transformation for both of the rigs. To do that, let's go to the item, disable all of the layers that are not needed. You're gonna need FK and torso. Now you need to figure out the frame range of the animation. In our case, that's going to be, oops, we need to look at that in the animated model. That's gonna be 82. So let's set that up. 82 in the visual transformers. Visually transform it. There we go. Let's hide this. The animated model, I mean. Now I want to find out the range for the other model, which is going to be stored here. That's 99. Let's hide it. Let's go to the other rig. Go to pose mode. Hide all of the layers that are not needed. Oops, my bad. I've picked IK instead of FK. and torso. I'll select all of the bones, go to BlenderOni, and now apply Bone Visual Transformer. There we go. Both of the rigs have now been visually transformed, and they now contain the animations. Now all you need to do is disable bone constraints for both of them. So go to Constraint Switches, bone constraint, and you can now animate the throw target. And now for the second rig, disable bone constraints, and there we go. We can now animate. Just like in the previous example, I'm going to assume that this is my finished animation, and now I want to export it to Oni. Before I do that, I need to apply visual transformation to the T-pose models. So let's select them. And now I need to figure out the frame range. That's going to be, in this case, 82. Let's go back. 82. No, that's 80. And now press Object Visual Transformer. Kanoko's T-pose, the model now contains the animation. Now we need to do the same for the other model. Let's hide this rig for now. Now we also need to figure out the frame range. Actually, I remember it. It's 99. Let's hide the rig. Select the hierarchy. Press Object Visual Transformer. And now you need to disable object constraints with Object Constraint Switch. Check if it moves. If it moves, it's okay. You can see the animation now. Now let's do the same for the other model. We can't move it. Let's press Object Constraint Switch. And that has disabled the constraints. So we can now move it, and we can see that the animation is now stored within the T-pose models. And now the attacker's animation is now ready to export. However, the throw target is not yet ready to export, as it is still not in a position that's readable for Oni. So what we need to do is select the pelvis and simply press Adjust Throw Target. And we can see that the throw target has reverted its position and rotation to the appropriate rotation and location. And both of the animations are now ready to be exported to Oni. Moving on to final use cases, change rotation mode and bake keyframe rotation mode were not used so far, so let's take a closer look at their use cases. So the one use case for change rotation mode is a theoretical one rather than a practical one, but nonetheless, let's assume that I want to import an Oni animation that's been converted by Oni split, but without using the blender tag. If you're animating for Oni, then you probably already know that if you want to animate in Blender, then you need to use the blender tag, because if you don't, this is what's going to happen. So as you can see, there's something clearly wrong with the animation, and actually the animation itself is fine. The problem is that Blender is not reading it correctly. So to explain that, the way Oni stores its animations is through XYZ Euler, which is being read as X first, and then Y as the second, and Z as the last one. That's Oni. But for Blender, XYZ is actually read in reverse. So Z is actually read as the first one, then Y, and then as the last one, X. So the way you prove that is by changing the rotation mode of each of those body parts of the character model to ZYX, and we have a change rotation mode for that. So select ZYX, press change rotation mode, and there we go. The animation is fixed all of a sudden, with the exception of the rotation. The way we fix it is we rotate it around X and by 90 degrees. And there we go. The animation is fixed. And we also have to do it for the remaining frames. Now, on a side note, the way Oni Split deals with that is by converting Oni's animation from XYZ over to quaternions, and then to ZYX, which is the XYZ in Blender. And then once you have the opposite operation, you want to convert an animation inside Blender to Oni, then you need to convert the ZYX, which is Blender's XYZ, again to quaternions, and back to Oni's XYZ. And that's how the blender tag works. As for the bake keyframe rotation mode, the funny thing about it is I actually don't remember why I've created it in the first place. All I remember about it is that I've used it for some purpose, but I don't exactly remember why. It was probably just me testing out how things in Blender work. Now, what you need to know about it is that this is a useful tool to convert rotation data of selected animated objects from Euler angles to quaternions and vice versa. So, as an example, we have Konoko here, which has its animation stored in XYZ. We can convert it to quaternions. Let's pick the frame range. That's going to be 16. And let's just bake it. And we will now see that now all of the objects are storing quaternion rotations as well, to which you can switch using change rotation mode. And there we go, the same animation, but now it's being read as quaternions. And this concludes this video. Thank you for watching, and I hope you will find this add-on useful in making new animations for Oni or in your own projects. See you around.